Hello everyone, welcome to Coders Camp. So today we are going to cover another interesting problem which is palindromic substrings. So the input given here is a string and we have to return the possible number of palindromes or palindromic substrings in the given string. So let's understand this with an example. Consider this is our input string. Here each character individually is considered as a palindrome. So overall the length of the string is going to be 6. So as single characters there it forms 6 palindromic subsequence. Other than that, AA is another palindrome, so we'll add one more, and BB is one more palindrome, and CC is one more palindrome. So overall it has 9 palindromic subsequence within the given string. So how are we going to approach this? The obvious first approach is going to be brute force, where we start iterating our string from the first character and compare every possible substring starting from the first character till the end, and then move our pointer to the second character. From the second character we'll consider all possible substrings and check each and every substring whether it is a palindrome or not. If it is a palindrome, then increment the count and calculate the total number of palindromes it can form. But doing so, it will work actually in quadratic time, that is big O of n cube. So how to do it in an efficient time complexity? Other than brute force, there are 3 different approaches for the same problem, but here today we are going to use expand around the corner technique, which we have already used in our previous video, that is longest palindromic subsequence. Here we are going to modify it a little bit to cover this problem. So what is expanding around the center? We are going to point at each character of the given string and ask the question whether this character can possibly a middle of a palindrome. So consider the string madam. So in this way, if we are considering the D as a character and if we point D, we are going to check whether this D can be possibly a middle of a palindrome. For that, we are going to compare the characters next to D. So now it's time to compare A and A. A and A are equal, so it can be a palindrome. So we are going to add one palindrome we have found to our answer. So further, since it is a palindrome, we are going to further expand it. So expanding to the next M and M is also equal at the both the ends. So we found one more palindrome. So we add one more 1 to the answer. So further there are no characters to expand. So we are ending and we found totally 3 palindromic subsequence in the given string. That is D itself is a single palindrome and then ADA and then MADAM is totally 3 and individually AM forms 4 more palindromes. So plus 4 it forms. If suppose the palindrome is MADDAM. So in this case you can't have a middle because it is of odd length. So in odd length you will find a middle character that's supposed to be the center of the palindrome. From the center you will expand. In this case it is an even length string. In this case you cannot find a single character as the middle. In that case you will have 2 characters as the middle. So 2 characters must be equal first. So if this is equal, we found one palindrome. So again in similar way expand around the corner. So after both the D's we are checking A and A, they both are equal. So we found one more palindrome that is ADDA, and since they are equal, further expand comparing M and M. So M and M again equal, so we found one more palindrome, we add 1 to our answer. So we gonna approach this using 2 ways, that is having a odd length, which means we have only single character as the middle of the palindrome, considering even length string which has 2 characters as the middle of the palindrome, and expand the string by considering the consecutive or adjacent characters, further expanding more till we complete all the length of the string. If at some point if the character is X here and M doesn't match, which means it can't be a palindrome further, so we quit the process and move on to check the next character as the middle. By using this technique, we are going to start from the first character of the given string and pass it to a function to check whether it possibly can be a palindromic subsequence. And we expand around the corner till we stop getting a palindrome. The same way, once this is done, we'll calculate the answers at by keeping A as the middle of the palindrome, how many subsequence we can form. Same way, once A is done, we move to the next A, again move to the B, until we finish all the characters in the given input. So what is the advantage of using this algorithm for this problem? For example, if we are considering every substring, we keep one character at the start as the starting point and other character as the ending point. So it needs two loops to point at the starting point and point at the ending point. But we are sending here only one character, considering whether it can possibly the middle of a palindrome. In that case, we don't need two loops at all. We just need one loop to iterate it and keep two pointers to navigate from the or expand from the center. By doing so, our time reduces to big O of n square from quadratic time. Hope you're understanding this concept. So let's see how the code is going to work. So let me declare an integer variable result, and I'm going to iterate through my given string to consider each character is the middle of a palindrome. So as I said, we are going to have two scenarios, that is single character as the middle and two characters as the middle. So to calculate that, we are going to use a helper method. So I'm going to send the center as I, I plus 1 for even length strings, and gonna get the helper method for same I, that is the middle character is a single character, for odd length strings. So once this is calculated, we are going to finally send the result. So now let's spend some time in writing the helper method. So we are going to compare if the characters at low and high are equal. If they are equal, then only we are still having the palindromic subsequence. If not, if they are different, we are going to break considering this character string further and move on to considering the next character in the given string. So I'm going to compare if not, if the characters are still matching, we are going to further expand and consider whether the string is palindrome or not. For that, we are in the middle, so low goes towards the left side and high goes towards the right side of the string. And every time we move the pointers low and high, we know we found a new palindromic subsequence. So we are going to increment our answer. For that, and finally return the answer. So yes, this is done. Let's run that. So yes, let's submit. So yes, the solution is accepted, and it runs faster than 97.17% of all submissions. So thanks for watching the video. If you like the video, hit like and subscribe. Thank you.